asks you for the subscription, the resource group, and then the region. I can select, say, Asia, let it be that way. You can give a resource name. You can say, um, so let's say you want to create an instance of API management service. You give a name. You say test APIM2, right? And then you give the organization, and okay, let's say. And then it asks you for the organization. So you give the organization, you say Canarys, and tell you why this organization is being asked now. And it asks you very rarely that the instances in Azure ask you for an email. This instance will ask you for an email. So I just give my email. So the reason that an API management service asks you for an email is, one, because an API management service takes a lot of time to initiate, to instantiate. So the moment you create, when I hit create, it takes about 45 minutes, in some cases 1 hour. And yesterday it took 2 hours for me to create, an instance. There was some issue, so it depends. So it takes a lot of time. So once an instance is created, you get an email. And the other reason, the other more important reason why the email is being asked is because this will be taken as the administrator email for all your API management services. So when you deploy an API and when you put some authentication or permissions or restrictions, so whenever somebody wants to get an access, and when they request an access, this is the email you'll get an email on this email that you've provided, saying that so and so person or so and so user has requested access. Do you want to approve or do you want to reject? So next comes the pricing tier. I will keep it developer for now. There are 3 pricing tiers. The fourth one obviously being the consumption, which is just plain pay as you go. The basic tier, the standard tier, premium tier. The difference is that there is a hierarchy or a quantity difference in the number of requests you can make through the API management service. So the basic tier is like you can make 1 million requests, and after that, each request is charged about I think 3 rupees. I'm sorry, I think every 10,000 requests after 1 million requests is charged about 3 rupees or something. And the cache, there is something called a cache, which I'll explain later. So this has something about 50 MB of cache, and the standard has 100 MB of cache, and the premium has some 500 MB of cache. So this is something that you can see in the pricing page. I won't dwell on it too much. So next is the monitoring. If you want some app insights, again, application insights is something that is prevalent on all services of Azure. So if you want to monitor the app and why it is not working or what are the failures and errors, you can enable it. I won't enable it right now. Scaling is not enabled for me. So managed identity, again, if you want some role-based access control, you can enable managed identity here. Virtual network, again, is so suppose you want only if you want infrastructure level security, and if you want only certain people accessing your service from a particular network, right? So if you have a Canarys network, you have a local area network where only people who are connected to that local area network have to access your API. You can specify that virtual network. So you can give the virtual network name. You can host that virtual network on Azure, and you can give your public IP address of that network, and you can make it internal, external. So you can do all that. So I won't be implementing the virtual network now. And then there is the certificates. So if you want an additional layer of application level layer of security, you can have SSL and TLS and HTTP2 also. So there are a range of security features for the application layer also. So Azure API Management Service has you covered at both the infrastructure and the application layers in terms of security, right? So next you create this. I won't be creating this because it will take a lot of time. So I have a few instances created already. So I'll use one of them. This is what I used yesterday, so I'll use this one too. So, okay. So this is the screen you will see once you switch to API management service. So what this has is in the left pane. I'll do one thing. I'll just go from the portal so that You get a full screen view. Okay. So as you can see on the left side, you have APIs, you have products. I'll just tell you what it is. Products is a collection of APIs. And products help you organize them and control those group of APIs in a much more granular manner. So I will explain products a little later. Then you have subscriptions. So if you want somebody to use your API, and you can have a choice whether you want to just put it openly to the public, like any website, you just put google.com, you go to Google, right? So, or you want a certain specific set of people who want to access your API, then you can provide these subscriptions where people can subscribe to your API and they get a unique key, and using that key, subscription key, only then they can access. So those are subscriptions. And so you can have your users and groups and all those settings related to the subscription here. And there is also caching. So if you want an external Redis cache, so suppose your API has a lot of requests coming in and going, so there might be some time lost from your API to the backend processing the requests. So you can use a cache. I will again, explain these things in detail. But I'm just giving you a picture of what the services and what features this API management service in Azure has. So what we will do is we will add an API. So what this is, just to give you a high-level picture, the API management service in Azure is a middle agent between your front end or your user and the backend. The backend is where your API is. So when you query a Twitter API, for all the tweets with hashtag Canarys, that is the backend. Okay, so Twitter is the one that is doing the heavy lifting. Twitter is the one that is processing your request and filtering all the tweets. If seeing if all the tweets have whichever tweets have Canarys as the hashtag and who is sending it, and so Twitter is the backend which is doing the processing and sending you the information. And in between comes this APIM, which will control, if you want, the flow of that information and the request and the response from the user to the backend, and vice versa. So that is controlled by this APIM. So what I'll do, I will add an API. So for now, we will add a very basic API. It is called the Demo Conference API. Okay, this is something that happened yesterday also, but I'll have another one. Maybe this is still not woken up. So, okay, I'll add it here. I'll change the instance. So what we can do is we can add an API. Okay, and we go to Open API. So again, in APIs, you have various types of APIs in the way they're architected and written. So the very vanilla type of API is the HTTP request, right? So HTTP request is like your web page. You just type in the address, you type into or the page or the sub page, and it takes you there. So that is the HTTP request. And then there's the WebSocket. This is something new, and this is something we all use, but we don't know. So things like WhatsApp and Facebook Messenger or Instagram, these are built with WebSockets. So WebSocket is an architecture where is a way of implementation of an API where there is a two-way communication. So you might be getting a message at the same time you will be sending a message, right? And these two things happen at the same time simultaneously. So your message is the sending of your message is not stopped because there's another message being received. So that is this method is called full duplex communication. So people from an electronics or electrical background might be aware of this terminology. There's something called full duplex. The rest other APIs are like half duplex, or they're not duplex at all, which means that you can either send or receive. You can't do both, right? And with a WebSocket, there is a continuous flow of data to and fro from the back end to the front. So like Instagram, where or WhatsApp, you just send a message, it goes to the server and just gets routed to the phone that has the other person's WhatsApp app. and from there it comes back to your phone. So this is something that is implemented with WebSockets. And then you have GraphQL, which is even more recently developed. It was developed by Facebook, and GraphQL is used where filtered or sorted data is required. So suppose you ask for all the tweets with Canarys, right? So you may get like 1 million tweets, but then you want all the tweets only from India. So in that case, what you can do is you can use GraphQL and query the Twitter API if it has a GraphQL implemented. You can query Twitter API saying that you want these tweets from this category. The other way would be to do it without GraphQL is to get all the tweets and then you sort it out on your native machine. So that is a little slower, but GraphQL is something that is being used recently. Then you have the Open API specification, which is a REST API implementation. REST is again representation of state transfer. So it is a standard for communication with web clients. So you have get and post, patch, put. So these are some things that you might have used at various levels. And then there is these two are old, WDL and WADL and WSDL, which is Web Application Description Language and Web Services Description Language. These are sorry, this is the XML this is the XML representation of the REST API. Generally, what happens, at least recently, what we've been using is the REST API gives data in the JSON format. But earlier it used to be XML, which used to be heavy and it used to be slow to parse the XML data. So, but then for making things compatible, Azure services offer these architectures also, these platforms also. So now coming to where you host the API, you can host it as an app at your server or in a cloud, or if you want that API to be functioning from a logic app, you can do that too. So these are the backends that are available. So suppose you want to host your API as a logic app, you can do that, or it's an app service, or it's a function app also. So, or you can containerize it and put it somewhere. It could be in AWS or Azure or any other cloud provider as a container which is running and taking in requests. You can add that as a backend too. So as you can see, API management offers you a whole host of platforms and features and makes it comprehensive for all API technologies to be improved. So what we will do is we will add an open API today. So this is it's a Microsoft created, API. It's just a test API just for, playing around. This is used for, I mean, at least the story behind this API is that, so let's say there's a conference and there are a lot of speakers and topics and there are sessions. So if you're building an app which takes data and shows users as to which session is on what day and who's the speaker and what topic. So this is an API you can use. So this has some data for testing purposes. So this is the address. This is where the backend is. Okay. So this is this site hosts the API. So once I click on Open API, this is the screen. I would go for the full specification. So I'll mention the address here. And then this is the name which I want to refer it to as. And so I'll just show you what this has. Okay, so this is a JSON document which has the specification of of the API. So what this says is that this has all the details for the API management service to take, and it defines the data types, it defines how many methods are there in that, and all that. So it gives you, so this is a specification document. So once you add that to the API management service, the API management service gets to know that what kind of an API this is and what features it has, what it returns, what it takes in as a request. So all that is given in this document. So I just have to add this document, and then I give a name, and then of course the URL scheme, I would prefer it to be HTTPS, but then if we don't have certificate on that, so just to be sure, I keep it as both. Now, the API URL suffix is something that you can give as you like. So this is so that if you have say 10 or 15 APIs in your API management service, and when you query your API management service, you have to have a link to it, right? A URL for each. Otherwise, if you just have one API, this URL will be sufficient. So this is the URL that from now on we'll be using to query our APIs, not the backend URL. Although the API is here and you can query it directly, but then that doesn't serve our purpose, right? If that is just a very innocent looking backend where it just takes in requests and gives you responses. But if you want furthermore control as to how much request it can take and who can request it and the authorization, authentication, and all that, you would want this API management to take care of that. So for that, you would have once you add it here, it will give you a link. So this will be the link that publicly we'll be using, or any other person who wants to query this API will be using, and this will be kept hidden. So what will happen is we can identify it by a separate URL, right? So I can say CanSpark API. So from now on, if you want to query this demo conference API, this will be the endpoint. Okay, so this will be the front end endpoint which your browser will be seeing, or your Postman, or any API querying app will be using. So gateways, I'll keep it that way, and I can do the versioning later also. So that's it. I'm good to go. I'll create it. Okay, it's already in use. Okay, maybe it's already there. Just give me 1 minute. Let me see. Oh, it's already here. Okay, so this is what happens when you create it. This comes up. So the API conference, the demo conference API is added here. So when you click on the API, it gives you all the details, right? It is taken it from the backend now. I mean, it is taken it from this document now. So as you can see, there is get topic speakers, right? And this is the get method. And get method has operation ID, get topic speakers, and all that. So that is what has happened here. Get topic speakers is somewhere here. Get topic, yeah, get topic speakers, right? So it's a get method. So all this is defined in this document. So these methods and what data type, what should be there in the request, and all that will be added, and the API management service understands that language, and then it gets added here. So at this point, I would want to just tell you that there are 4 levels of applying policies or properties in an API management service, which is the global level, which means that it is applicable to all APIs and products. Again, products are collection of APIs, and it's applicable to all the operations in the API also. So that is a global level. And then there is the API a policy or a property to just one of these APIs, and then there is the operation level, where you can apply some policy for one particular operation, and the other level is the product level. So if you can group 2 or 3 APIs into a product, and then you can define a policy for it. So that is how the scoping of the policies is structured. So now what we will do is I'll just show you how this demo conference API is functioning, and we can just test this. So the API management service provides you with a testing environment also. This is pretty much like your Postman, or any HTTP request platform that you might have used. There's Hopscotch also, so it's pretty much the same. So, but then this is restricted to only those APIs that are added in this service. Okay, so you can't just query any public API. So first you have to add this here, and then you'll have to query it. So let's say we'll check this, right? So it takes in, as it says, it takes in an ID, and the value should be of an integer type. Okay, and so we'll say 101, and then we send this. So we get 200, okay, and this is the thing. So 101, the session number 101 is async in C#. C#, it gives the description of the session. And as you can see, what was in the request? It sent a GET request to this ID, right? This URL with this session ID, right? So that is the session ID I gave. So this was a string, and the session ID was concatenated to that URL, and then it sent a subscription key, which I'll come to later, and then a trace. Trace is also asked. The trace is here. So trace is something that gives you the detailed picture of what went in and what came out and what was processed also. So this is what was the inbound. You can see that you have a get method here, and then you have this is the ID, and then all the other details. This is subscription key. So then you have the outbound where what comes out is the response of the API, the cookie, and all that. So that you can play around with this API. You can just say get topics, right? And you can say you just query this. I'll just show you. So let us say there are a number of days, and we'll say first day. So it gives a response 200 OK, and then these are the topics available. This is architecture title. There's architecture title is agile. There's cloud. So all that. So this is a JSON schema that's coming. As I said, in Open API, we use JSON for REST requests. Okay, so now what we will do is, now that this API is added to the API management service, we want to know, how we can control the inflow and outflow of information, right? So let us say we have added this and then we have given it to our developers, right? Probably our organization has some agreement with the person who has created this API, and then this API is hosted at his infrastructure, on his platforms, on the physical infrastructure. And then let us say he's charging us for every request. So, but then we want to use this and we want to add it to our developers and our engineers, so that we want to create some service from this. So how do we do this, right? We want to encourage the correct use of this API, but we also want to restrict the misuse or erroneous requests also, because it's costing us money. Or if we are hosting it, we still don't want our servers to get overloaded or deny a genuine request because it's running some other request. So these are things that we can do from the API management service. Again, like I said, at 4 levels. So suppose this is an API you are concerned that a lot of people will be using and quite frequently querying it. We can add some policies. So for that, we go to the design view of this API. So when you click on this, you go to the design, and then let us say a very fresh programmer who's not very well versed with his craft will put your API request in a for loop, and then the for loop does not exit, right? There are many chances where the for loop is not exiting and the for loop is going on in an infinite loop. So what happens then is that your API is being queried infinitely, and your server is getting requests every microsecond, millisecond, and then your server is getting overloaded. So what you can do in that case is that you can set a limit and say that my API, I'll not allow my API to be queried more than say X number of times in Y seconds or minutes. Okay. So what you can do is that you can add a policy here. You can say add policy, and these are the number of policies that Azure APIM offers you. So there's something called limit call rate. I'll go through the other policies also. There's something called limit call rate. If you specify limit call rate, so you can say that I want only 5 calls. I will allow only 5 calls to my API in the next 1 minute, or every minute from a particular user, I will allow only 5 calls. So that way your server is not getting overloaded, right? Now this you can specify it, is it only the subscription or from an IP address, or so I was saying, you can restrict the access or the number of calls from a particular subscription or from a particular IP address entirely. Or you can set some other criteria where you can define it in the code. I'll show you later. So I'll keep it API subscription for now. And then it asks you for the increment condition. So how do you count a request? So is a request just a call, or is a request a successfully executed API response? Where, say, suppose there's an API request made, and then it fails for some reason, or if there's an error in the request, is that still considered as a legitimate request, or only requests that have a successful response will be considered a request? So that is something that you can specify. Is it just all requests or successful requests? So I'll say it's successful requests, right? So if the request is a bad request, that will not be counted as a request. Okay, so that will not be counted for these this 5 requests per minute policy. So I just save, and you can see that it will not allow us to make more than 5 calls for the API in a minute. So just wait a minute till it applies. It's taking a while. Okay, applied. So what we can do is we can see now that if you want a topic, I've applied it for the entire API, right? I can apply it to any one of these operations also. So now I applied it for this API, the entire API. So all the operations, any operations that you query, you can only query it 5 times a minute. So I'll say, let's say get topic. Okay. So I did that already. So I'll say on the day 1, okay, and I query it. So this is my first request, right? So it's successful. I get a 200 okay response, and then on the day 1 there is agile. So next I say what's on the second day. So it's architecture, okay. So I go for the third day, right? And that says okay too. So then on the third day we have cloud as the topic, okay. Fourth. So as you can see, I'm doing this within a minute. So it's been hardly 15-20 seconds. And this is the fifth response, fifth request that I make to the API. So I still get a response. Now let's see what happens. So sixth response, let's see what I do on the I want to see what's on the 6th day, right? What is the topic on the 6th day? I send this, I get a 429. So it says, there's too many requests, you have to wait for a minute. Right, and this minute, the time starts from the first request. So it also tells you that until 13 more seconds, you can't make another request. So if you just count 13 seconds and then make a request, it will allow this request. So let's just see. Oh yeah, see. So 13 seconds went by, and then you get an okay. So you get a response for that, and it says okay. On the 6th day, there is DevOps. Okay. So this is something that you can set again, as I said, for the product, which is let us say I make a product with these 2 APIs, the Echo API and the Demo Conference API, and I can say that for the entire product, anybody can query it only say 10 times a minute, or say 100 times an hour. So such policies can be set, or you can set it only for this API. Say this API is in demand, and you want to restrict misuse of it. You can specify the number of requests for that, or you can specify it only for this operation, any operation. So let us say you have a database operation where data is being sent to your database a lot, and then or very quickly. So you want to put some speed bump on the way data is being written to your database, because a lot of times what happens is that when your database is being constantly written to, the database locks, because for the sake of consistency, the database will lock so that the read operations are consistent. So to prevent that, you can put a restriction on the post operation also, so that a lot of requests to write to the database is not it's not very fast, so that your database is always locked. So I'll show you other policies. So I'll just you can remove this policy now. I can just say delete, and that policy goes away. So I'll save. Okay. So there's another. Okay, save. Okay. So then the other policy is filter by IP addresses. It will be very hard for me to implement this here, because there are no static IP addresses that I know of. So if there's a service that has a static IP address and you want to allow only that address, or you want to disallow that address, you can add an IP address here, and it will allow or disallow as you set it to. Then you have mock responses, another interesting policy which I'll come to. But there's something called I'll go through the others and I'll show you a few. There's something called validate content, where suppose you don't want some attack or some exploits that are being carried out, you can validate the content in the request from here itself. Okay, and you can validate the parameters that are sent when you're querying in the URL itself. You can send certain parameters which you can validate here. Then there's something called the set usage quota. So quota by key is you can filter the requests by the number of by the bandwidth or the size, the file size, or the bytes of data that is being sent. So you can again do it by the number of calls, or you can do it by the bandwidth, right? Or you can do both. So what happens with the bandwidth is that if, say, your API is being queried and your API is not just giving you text data, but certain other links, and say in a GraphQL sending you pictures also, and then your bandwidth is getting jammed, you can restrict the querying of the database, of the API, as to only so many kilobytes per request, or so many kilobytes per IP address, or per subscription. So you can set that for such and such a time, say for 10 seconds or for 5 minutes. Here it's 10 minutes is the minimum amount for this policy to be applicable. So for 600 seconds, let's say from a particular IP address or a particular API subscription, you will allow only, say, 10 KB of data, 10 KB of data, and you will allow only, say, 25 calls, right? And you can set that. And people exceeding, or the requests exceeding these criteria will be rejected. So that is something that you can do. I won't be doing this right now because it's difficult to measure the throughput of the response as to how many KB it is and all that. There's no good tool available right now. So the other thing that I want to show you is the mock responses. Say, suppose you're developing an API and then it's not available, it's not ready yet. Okay, and you want to, but still your front-end team wants to test your API responses. But your backend is still not ready. You're still programming it, but for a fact that what the response will look like. Say, suppose there is an operation. Let us say, I'll add another operation. Let us say there's an operation that says for a topic, let's say get attendees by country, right? Okay, and it's a get request, and I'll just say, and I just put, okay. So suppose this is still in development, right? You want to develop an API which it just tells you all the attendees to the conference by the country. You want to group it, and you want to say that so many people from so many country and all that. But this is not ready. But still, you want to allow the front end team to test this. So in that case, you can create something called mock responses. What you can do is that you can just give a test response, a dummy response, which you can just specify what the response will look like, just for the sake of testing. So what you can do is, in case of a 200, it gives you all the response codes. So suppose your API processes a 200 response, and then the description that you want to say, suppose you want to give it a description. Success query. And say you want, okay. So the way your response should be, it should be a JSON format, right? So you do application/JSON, okay, and then you give attendees, right? Like this. number should be a number. Say 100 people have come from country would be India. Okay. So that's my response. So I'll save this response here. And what I'll do is I'll enable a mock response for this. So anytime just have different status codes. Okay, I have to remove this because nothing there. Okay. So because so when you enable a mock response, any request to this operation will give you the same response. So again, like I said, this is just for the testing purpose. So when I save this, okay, why? Seems to be an error. So query description. Is there something wrong? Object basis. Oh. Not sure why it's throwing an error right now. Could not save. It says could not save. Not sure why. User body. No. This is template. Call request. There's a request and response. Okay, let's discard this. Let's see. I'll go to the front end and do it here. Okay. Oh no, this is taking the code window. So yeah, so this is something that you can do at the code level also. So again, this is a JSON object where you can create a mock response, but I'm not very comfortable with JSON, so I'll do it back in the GUI itself. So let's say I create a new operation, and I don't know, again I say by country. Okay. Just do APG for short, and description will be and response to be this. I'm not sure of the right format of JSON, right? Just give me 1 minute. I'll see. So in the meanwhile, I think it's 4:50. We just have 10 minutes. I'm open to any questions. We also have a second session on the coming Thursday. I'm open to questions. In the meanwhile, I'll just fix this issue. So if you have any questions, please do let me know. Any questions on the content I've covered till now or anything regarding API? Okay, that'll do. So I've just put some content just because I'm too lazy to type JSON. This will be the body. I hope it saves now. Okay, seems like it's saved. Right. So I've created a mock response. I've created a response. Now what I'll do is I'll enable a mock response policy here. So I add it here. I say there's mock response. Yeah. So what I can do is I can give the response code. So I can say that for 200 requests, for a 200 response, that is the response that I want to give, right? In any case, whatever the request may be, because my backend is not ready yet, I can specify for all successful requests, this will be the response. I can enable it right now, and whenever I query it, that will be the response. So see, and it also shows you that mocking is enabled, so that you're not confused if that's the actual response or it's coming from the backend. Also, I forgot to mention that this is a block diagram of how the API request flow goes through. Okay, so this is the front end, which would be your browser, your client, your postman, or anything. This is where the request is generated. For now, we are doing it from the test screen. So this is where this is as good as the front end. So from the front end, your request is generated and it goes into the inbound processing module of the API management service. So in the inbound processing, you can specify the policies, which is, like I said, caching policy or mock responses or quota limits or rate limits. And from then, if those policies are fulfilled by the request, it goes to the backend. The backend is where the API actually resides. And the response is generated by the backend. You have very little control here because this is hosted somewhere else. It's not in the API management service. So it comes back to the outbound processing. So even in the outbound processing, what you can do is this is a very important module of the API management service, which I hope I will take it up in the next session. You can say, suppose there are some connection strings or passwords that are being processed and sent by the backend. You can eliminate those. Or you can do post response processing, right? Once the response comes, you can process the response and send only what you want to send. So that is something you can do in the outbound processing module of the API management service, and then it comes back to the front end. So for now that we've created a mock response, we've enabled it. Let's test. Okay, so it reminds me that mocking is enabled. I'll just send a request. So I get a 200 response. Although I have nothing in the backend, this is what it comes, right? This is what I copied from somewhere, from here. So that is a response that is being generated. So the mock response will enable the front end team to test, so that they can take this and do their testing. So this is, I think it's we're just about to close because we're out of time. I'll be opening up for questions. If you have any questions, please feel free to ask, or I'll see you in the next session again.